Hey everyone, welcome back to my channel. In today's video, we'll dive deep into the most powerful machine learning algorithm, the random forest. Not only will explain what it is, but we'll also build a random forest model, visualize it, and apply to the real world dataset. So let's get started. First, let's quickly understand the what random forest is. So random forest is an ensemble learning method, which means it's combined multiple models to create a stronger, more accurate predictor. So that's a basic definition. And especially it combines multiple decision tree, as you can see in this diagram. So it's a forest of a decision tree. The final prediction is based on the majority vote or average prediction from all the individual trees. So each tree in the forest is trained on random subset of the training data, and this randomness helps the model makes the model more robust, reducing, reducing the risk of overfitting and improving its generalization ability. So random forest has a lot of advantages. First, it's extremely powerful and works well for both classification and regression tasks. Since it uses multiple trees, it can handle large variety of data types, including numerical and categorical variables. So advantage of random forest, high accuracy, handle missing values, can model non-linear relationships, and works well with the large dataset. It is also less prone to overfitting compared to single decision tree, especially when there is a large amount of training data. Plus, it's a great at handling missing data and can model non-linear relationships. So now let's get this into the fun part. We are going to build random forest model in Python. We'll use the famous iris dataset, which we've been using in few of the videos, to predict the species of flower based on the features like sepal length, sepal width, petal length, and petal width. So for this, let's first load import our necessary libraries. Next, we'll import the dataset. The X will be the iris data and target is the type of the flower. Features and target names, just putting into these variables. Now next, we'll splitting the data into training and testing sets. The next part is initializing and training the random forest model. So I'm just importing the random forest classifier. And next is making the prediction. So that I've stored in Y, right? And the next is evaluating the model performance. In this case, we should get one because it's very fairly small data set. Now, so we initialize the random forest classifier with 100 trees. So an estimator in uh, this argument is the number of the trees and fit the models on the training set. After making prediction on the test, we evaluate the accuracy using accuracy score. So random forest can be hard to interpret because it's an assemble of many trees. However, we can still visualize individual decision tree with, within the forest to get some insight into how they make decision. So in this next code, we are going to use the plot tree to visualize the final decision tree in our random forest. And we can see the condition each tree use to make decision at each node, which feature is considered and the final prediction. So if I run this, as you can see, this is the visualization of the decision tree in our random forest. And as you can see, this is just one of the 100 tree in the forest. Each of these tree might make slightly different decision based on the random subset of the data and random feature selection, but together they form a highly accurate prediction. So while random forest is powerful out of the box, we can improve its performance by fine-tuning parameter, which can be done if we add more or use the maximum depth or an estimator to improve the performance. So those are the hyperparameter which we can use. Now let's take the render forest beyond simple data set and apply it to real world problem. Imagine we have a data on the houses, including which includes features like square footage, number of rooms, location, etc. And we want to predict the house price. So for this, let's reload our libraries. So we are going to fetch the real world like data set, housing prices from scikit-learn dataset, right? And the X will have all the columns which we are going to use for prediction, and Y is the price, house price. So if you want, we can actually see the prices data set. So this is the data set we have, which are with the 85 rows, and 5 rows just ahead, which faces the first 5 rows, and 80 other different columns you should be using. Next, we are getting all the columns which are of the categorical means in the categorical types, and we will convert those category columns to numeric so we don't get any error while fitting the data set. So if we run this, and we are also checking if there are any missing values. Next, simple, we are splitting the data into training and testing set, initialize the model and making the prediction. And let's evaluate the model using the mean absolute error, which is coming at the 17,630. So yeah, just to add on the label encoder, so it's convert each category into numerical labels, which is required while fitting the data. So that's it. So this is just two example on the red forest, and as I said, it is very powerful machine learning assembler. Thank you for watching. See you the next time.